Hi guys, and welcome to Learn Extra Live Grade 11s. It is your turn finally, and I've got Tamlin next to me.
How are you doing?
Oh, so good. It's Monday, and it's going to be a fabulous one.
It will indeed, yeah, absolutely.
Yeah. So today we're going over quadratic equations.
We are. It's a really important section in our grade 11, and obviously going all the way through to grade 12.
So hopefully there's some grade 12s watching too, right?
Absolutely. It's always worth the revision, so for sure.
Fantastic. Okay, go take your little
Thank
spot
you.
by the board. Okay, guys, if you didn't know this yet, let me tell you right now. Let me have a look for this little link over here quickly as well. So now we have got all of today's show notes. We have all of today's show notes available for you to download from our website, which is pretty cool. So all you have to do is you need to go to www.mindset.co.za/learn/extra/live. Now, if you can't remember that or you haven't had time to get your pens and papers out, I will be posting it onto our Facebook page, and that's facebook.com/learnextra. Or you can get it from Twitter @LearnExtra. And if you need it, just post it and I will make sure that I send you all of the links you need, guys. And a big up to our sponsors, Macmillan. You guys rock. Thank you so much for making this show possible. We really appreciate it, and we love you guys lots. So now I think it's time to get learning more, learning extra. Tamlin, take it away.
Thanks so much, Indy. Right, grade 11s, let's get going with a bit of quadratic equations. Okay, the first thing we're going to do is just go over what we're going to be covering this lesson. And just to have a quick look at it, first thing we're going to have a look at is working with quadratic equations just by using factorization. So that's generally sort of our beginning stage type equations. Then we're going to have a look at them where we're involving fractions, that's everybody's favorite. Then after that, completing the square. I'm sure by now in class you've already had a look at that, so hopefully we can, if you're feeling a little bit unsure, we can clarify that for you. The quadratic formula, which is always very handy when we cannot actually factorize an equation and we need to find the roots or the answers for x. And finally, something very interesting where we can find the maximum and the minimum values of a quadratic equation by means of completing the square. So lots of interesting stuff we're going to be covering today. Okay, having a look at our key concepts. Let's just quickly have a look at what it is that we need to be aware of here. Quadratic equations in one variable, so bearing in mind that we're working with just an x variable, are equations that can be written in the form ax squared plus bx plus c equals 0. I know you guys recognize that. That's our standard quadratic equation. Okay, because the highest power, because we're raising the highest power of x is 2, it means that we are going to land up with 2 solutions for our equation, okay? And just to remember that what we call the solutions of our equation are roots. So when your teacher refers to the roots of your equation, she's referring to the answers that you are getting when you solve that equation. Thereafter, we have a look at quadratic equations which cannot factorize perfectly. And this is when we have to look at the possibility of using the quadratic formula or the possibility of completing the square. Just to note, grade 11s, that if you want to solve for x and it's a quadratic equation that does not factorize, if you're going to use the method of completing the square, generally it's a method that they ask for, okay? So if you have to just find the values for x and you don't have to use completing the square, generally it would be recommended that you use your quadratic formula as the more user-friendly of the two. And finally, then just to talk about completing the square and where we actually are going to use it. Okay, this over here we've already just spoken about. We can solve it, we can use it to solve the values of x, and also to find that maximum and minimum value of a quadratic equation or a quadratic function. So that's where we're going to use those that completing the square method. Okay, grade 11s, let's get stuck into a few examples. Right, going from the very beginning where we're just going to solve a quadratic equation by factorization. Okay, a few things to look out for. Firstly, we know it's a quadratic equation because we have got an x squared. Okay, it's not linear. Linear would be defined by having just x to the power of 1. Quadratic, we're now working with x squared. The next thing, when you've got a quadratic equation, please make sure that all your terms have been brought over to the left-hand side of your equation and that your right-hand side of the equation is equal to 0. Okay, you must have it in that format over there. Once we've got that, so in this case I didn't have to do any rearranging, it was already in that form. The next thing we're going to do is to factorize. Okay, let's see if my trinomial factorizes nicely. We've just had a lesson on grade 10 factorizing, so I'm sure if we were watching, we all should be pretty familiar now with how to do it. We're going to have our 2x and our x. Factors of 2, well, we obviously don't have too many options there. It's just 2 times 1. It's just where to position them, okay? I'm going to put my 2 and my 1 in the positions as you can see them there. And the reason why is this. If I make this a positive 2 and that a negative 1, if I were to FOIL this out, I would get a positive 4x when I multiply my outers, and a negative 1x when I multiply my inners. And that's then giving you the positive 3x that you wanted as the middle term. So just once you've factorized, as Dina mentioned earlier, check it. You can always check it and see if you actually are correct. So just quickly do a FOIL sum in your head and make sure that you do get back to what the original question was. Then you know you factorized correctly. Okay, so once we factorize, the next step now is to take each of our brackets and make them equal to the 0. So I've got 2x minus 1, which is equal to 0, or we've got our x plus 2, which is equal to 0. Okay, and we solve for x. So therefore my 1 comes over and I'm going to divide by 2. That's my first answer for x. Or I have negative 2. So the roots of my equation 2x squared plus 3x minus 2 work out quite nicely here to be a half and negative 2. Okay, so that's a pretty introductory example. I'm sure you guys are all comfortable with that. Just make sure you know how to factorize. That's obviously really important to remember. Okay, now let's look at one that maybe is a little bit more involved. Okay. At the very start of it, I can't see any x squareds, okay? So at the moment, it doesn't really, as I say, there's no x squared, so it might not be a quadratic equation, but what we are going to have to do is start off by getting rid of those brackets. We need to tidy up. And by tidying up, we're going to find that we'll probably get some x squareds involved here. All right, first things first, we are going to distribute into my bracket to get rid of my bracket on this side. And I'm going to have to FOIL my 2 binomials on that side of my equal sign. All right, so therefore we are going to get 2x squared minus 2x plus 3 is equal to, now when we FOIL out our brackets, I'm going to get x squared. When I do my outers, so when we do our outers, I get negative 4x. And when I do my inners, I get negative 2x. So together, negative 4 and negative 2 give us negative 6x. And when we do our last, negative 2 times by negative 4 is going to give us positive 8. Okay, so step 1 dealt with. We've now gotten rid of our brackets, and you can see now that we've got x squareds in our equation. So it looks like we've got a quadratic equation to deal with. Let's gather all our terms to the left-hand side. Let's make everything on that side. Let's get our right-hand side equal to 0. So doing that, I'm going to have 2x squared minus 2x plus 3. I'm then going to have minus x squared plus 6x minus 8, which is equal to 0. Okay, let's just add up like terms here. I've got a 2x squared minus a 1x squared, which is going to leave us with just x squared. I have got a negative 2x plus 6x, which is going to give us positive 4x. And I have got a positive 3 minus 8, which is going to leave us with negative 5. And it's equal to 0. Right, so we've got a quadratic equation because we've got our x squared. All of our terms are on the left-hand side. Right-hand side is equal to 0. We're all set up to now just finally solve our equation. Okay, so let's factorize. The reason why this trinomial is a nice easy one to factorize is because there's actually just a coefficient of 1 in front of my x squared. If there's anything other than 1, it makes that trinomial just slightly more complicated to factorize, but I'm sure by now your teacher's given you a nice method that you can work with in order to do that. Okay, so factors of x squared is obviously just x, and factors of 5, we're working with just 5 and 1. In order to get my signs right, my 5 will have to be positive and my 1 will have to be negative. So therefore, to solve for x, we have got x which is equal to negative 5, or we've got x, which is equal to 1. Okay, and again, those are the two roots of your equation. All right. I hope so far so good. You guys are all following us. Let's see if we can have a look at one that's a little bit more complicated. Right, fractions, as I said earlier, everybody's favorite. They're really not that bad. We just have to take it carefully, one step at a time, and not to forget your basic rules of fractions, such as if you're adding or subtracting fractions, just like we did way back when, we still have to find lowest common denominators. And our golden rule of fractions, whatever you multiplied the denominator by to get that LCD, what you do to the bottom, we're going to have to do to the top. So we've got to follow those basic rules, okay? Let's have a look over here. I'm actually going to start by balancing this over here. I'm going to put that over 1, because I just like to have my equation balanced. If one part of it is a fraction, let's make all of it a fraction so that we can clearly see what's in the numerator and what's in the denominator. Okay, so we're looking for a lowest common denominator. I think you all agree with me on that. We've got a 1, I've got an x minus 2, and I've got a 2 minus x. Okay. X minus 2 and 2 minus x, unfortunately, are not the same thing, okay? They will give us different values if we substitute the same value of x into each one of them. Therefore, what we're going to have to do is see if we can manipulate this to become x minus 2, all right? Let's think about it for a second. If I were to take a negative, out of this bracket over here, let's just do that over there. I want to swap this around to become x minus 2, all right? So what I've done is I've taken out a negative, and I've inverted the two signs. I've changed their position, okay? Now, why can we do that? Why is that valid, and why is it not changing the value of anything? The reason being is that if we were to distribute this negative back into the bracket over here, we would land up with a negative x, which is what we had in the original bracket. And if I said negative times negative is positive, I would get a positive 2, which is what we had in the original bracket. So we haven't changed the value of anything. We've just changed the way it looks slightly, okay? All right, so just to make sure everything looks neat, I'm going to erase that for now, and let's go ahead and find our LCD. Okay, let's give ourselves a nice straight line. So I've got my left-hand side and my right-hand side. And my LCD is going to be, we're not going to get there just yet, in fact. Let's put that over 1, and I've got my x plus 3. And I've got my equals, and I've got my x minus 2, which my numerator of 3x plus 3 is not going to change. Okay. Now, what I'm going to do is just put it over there, is I'm going to change 2 minus x to x minus 2. But in order to do that, as we said earlier, we've taken a negative out of the bracket. Now, a negative over a negative will actually become positive, okay? So the negative that was in the original question has now changed to positive. You must clearly show that. I'm quite sure that will be worth a mark in your exam, okay? Right, so we've changed that to positive, and as a result, we now have an LCD, which is going to be x minus 2. Our numerator, sorry, let's just leave that there, is 4x minus 2, okay? Right, so what we are going to do then is we are going to have to, remember the rule was what we do to the bottom, we do to the top. So I'm going to have to multiply this by x minus 2. This is just multiplied by 1 and multiplied by 1. Okay, so let's just quickly do this. And we've got our equal sign in the middle. Right, I've got my x plus 3. And I've got x minus 2. I've got my 3x plus 3, which I don't need to multiply by anything because it's already over the lowest common denominator. And 4x minus 2 is already over the lowest common denominator, so I don't need to change anything. So x minus 2 is our LCD. Right, if we have now found the lowest common denominator on either side of our equal sign, we are now able to drop that denominator. However, there is something that we must remember to consider, and that is what we're going to refer to as the restriction of this equation, okay? if we think about it, we know that a denominator of a fraction is not allowed to be 0, all right? So therefore, does everyone agree that if I were to solve for x, and I would land up with an x value of 2, 2 minus 2 is 0, and that would be a problem. That would then leave my solution as undefined, and that would not be a valid answer. So therefore, with our restrictions, we must state that our x is not allowed to be equal to positive 2. Okay, that is my restriction on my denominator. So we're going to drop the denominator, and we're now going to just solve the equation. So we've got x squared. I have got plus 1x. I've just done the FOIL in my head there. Hope everyone's followed that. And that's going to be minus 6. I've got 3x plus 3. I've got 4x minus 2. Okay, so let's gather all our terms to the left-hand side. So I've got x minus 6. That's now going to become minus 3x minus 3 minus 4x plus 2 equals 0. Okay, let's add like terms. X squared, I've got x minus 3x, which is going to give us negative 2, minus 4, which is negative 6x. And I have got a negative 6 and a negative 3, which is going to give us negative 9, plus 2, which is giving me negative 7, equal to 0. Okay. And we can now factorize it, just as we did in the previous two examples. I've got x and I've got x. Factors of 7 really just leaves me the option of 7 and 1, of which 7 is going to be negative and 1 will be positive. So x is equal to positive 7, or we are getting negative 1. Are either of those solutions or those roots the same as the restriction that we looked at earlier? Let's just double check. The restriction was that we were not allowed to have an x value equal to 2. So just double checking, obviously neither of them are, so therefore my solutions, if I substituted x back into the original equation, I would not get an undefined solution, so therefore it's valid. Right, guys, I hope that that's all clear to you. And I think before we get going with some completing the square, we're going to take a short break. Am I right?
It's time for a break.
Already?
Okay, before we go, guys, happy birthday to Facebook. Facebook turned 9 today. I can't believe it. It was just yesterday that Facebook didn't even exist, and now it's a whole 9 years old. Happy birthday, Facebook. And guys, get some water because it's very important for you to keep hydrated, jump up and down, keep that energy going. We'll see you now after the break. Hi guys, and welcome back. I hope you're enjoying the show as much as I am. There are so many mindsetters on the page, and you guys are all helping each other out, which is fantastic. It's exactly what we want and what we need. Lucinda says, "Hello back, mindsetters, enjoying maths and the notes that come with it." That's very important. So Lucinda, I'm so glad that you have downloaded today's show notes and you're working alongside with us, because that's what we want to start getting. Also, if there's any questions that we're going through that you don't understand, please let us know on the page. We know that you are posting. There's one or two of you that have posted questions and you've asked us if we can please go through. Unfortunately, mine says we don't have time for that, but what we do have time for is asking those important questions. If Tamlin's going through anything you don't understand, ask us on the page and I'll say, "Hey Tamlin, they've got a question for you," and then I know that she'll be she loves questions, don't you, Tamlin?
For sure, always.
So
okay,
take it away.
Go. Let's have a look at another one, guys. I'd like to have a look at this question just before we do go on to completing the square. It allows us to just deal with the factorizing in the denominator if we need to. Okay. Right, let's have a quick look here. Similar to what we were dealing with in the previous question, we've got fractions which we are adding. So as we said earlier, we need to find lowest common denominators. Okay. So looking at it, now obviously no one wants a denominator with that big a trinomial in it. So therefore the idea is you obviously need to factorize all of your denominators as much as possible. Okay, we want to try and keep our lowest common denominator to exactly that, the lowest common denominator. Okay, so what we need to do over here, guys, is let's see if we can factorize this denominator here. I've got factors of 12. Now, a mindsetter actually has asked on the page, how do we know which factors to use? This goes back a couple of years, sort of into the beginning of factorizing, but just to clarify for you if you are a little bit unsure. we need to look at the last term, okay? So in this case, we're looking at 12. And you need to say to yourself, what are the factors of 12? What times what gives you 12? So in this case, I could say, well, 12 times 1 is 12, 6 times 2 is 12, or 3 times 4 is 12. So I've got a couple of options over here. Now, the option that you need to decide on is the one that's going to get you this number in the middle. So in this case, we're looking for a 7, okay? So if I took a 12 and a 1 and I added or subtracted, that's not going to get you 7, so we're not going to be able to use that, so that's out. 6 and 2, if I add or subtract them, once again, it's not going to work. We're not going to get to 7. So that leaves me with 3 and 4, which if I add them, it is going to get me to 7. So therefore, when we factorize the trinomial, we are going to have a positive 3 and a positive 4. Okay. Which means that what is my LCD going to be? Let's just take that away and let's write it over here. Our lowest common denominator. I've got an x plus 3 over here, and I've got an x plus 3 over here. So we're going to have x plus 3 in my denominator. And I've got an x plus 4 and an x plus 4. So I am going to put those over there. Okay. I'm going to do the rest of the question, but for those of you who are watching carefully, what I would like you to do is post in for me while we're busy with this. What are the restrictions going to be on this example when we finally look at the answer? See if you can send those to India quickly.
I love that, because they keep asking for like little tricks and questions on the page. So guys, get posting now, facebook.com/learnextra.
There we go. So I want to know, what will the restrictions be on this equation once we're done with it and when we have to check it? Okay. Right, lowest common denominator is going to be x plus 3. And it's going to be x plus 4. And x plus 3, x plus 4. Okay. Right, my numerator, this numerator over here, let's change our color pen. I've got x minus 2 as what was there originally. And this first fraction was only over x plus 3. So therefore, we had to multiply it by an x plus 4, because our rule is what we do to the bottom, we have to do to the top. This denominator had both the x plus 3 and the x plus 4, so therefore I don't need to do anything than actually multiply my numerator by just 1, so therefore I've got plus 12, all right? This denominator was only x plus 4, so therefore what we've got in the numerator, which is 2 minus x, needs to be multiplied by x plus 3, okay? As far as the denominator goes now, we can drop it as long as we remember our restrictions, which I'm sure you guys are all working hard at figuring out here. Okay, now we need to simplify this out. So I've got x squared. I have got positive 4x minus 2x, which is going to give me positive 2x. And I have got negative 8, and I've got plus 12. On the other side, if I FOIL this out, I'm going to get a 2x. I'm going to get a positive 6. I'm going to get a negative x squared and a negative 3x. Okay, so we've multiplied that all out. Let's follow the same procedure. Let's gather everything to the left-hand side. We want our right-hand side to be equal to 0. So we've got x squared plus 2x minus 8 plus 12. We'll tidy all of this up in a second. Minus 2x minus 6 plus x squared and plus 3x, which is equal to 0. Okay. Like terms, I've got an x squared and an x squared, so we have got 2x squared. I've got a 2x minus a 2x. In fact, those two have cancelled each other out, and we are left with 3x. And I have got a negative 8 plus 12. That's going to leave us with positive 4. Positive 4 minus 6 is going to give me negative 2. Equals 0. Okay. And let's factorize. Right, so I'm going to have a 2x in the first bracket and x in the second bracket. My factors of 2, I'm going to have to use the 2 and the 1. I want this to be positive and this to be negative, just to clarify why. Remember we said to you, do FOIL. Go back and see if you actually, when you FOIL it out, if you get back to your trinomial. Okay. And let's solve for x. So my first answer for x is going to be a positive half, and the next answer for x is going to be negative 2. Right, so now we have to consider the restrictions. Okay, Indy, is there anyone who's managed to tell us what the restrictions are?
Not yet.
Not yet. Okay, I'm sure you guys are all
Come on,
busy
guys. Type in
working
curious
it
your
out.
way, hey?
Okay, let's confirm what I'm sure you're already thinking. If I have got a bracket of x plus 3, remember the idea with your restriction is that the denominator is not allowed to be equal to 0, okay? So look at this bracket. If I've got an x plus 3, what's going to make that bracket 0? If x is equal to negative 3. Negative 3 plus 3 would be 0. So my first restriction is that x is not allowed to be equal to negative 3, all right? And the same would have to apply to the second bracket. If I've got x plus 4, if my value for x was a negative 4, it would once again make the bracket 0, okay? So the other restriction was that x is not allowed to be equal to negative 4. So bearing that in mind, are either of my solutions one of my restrictions? I've got a negative 3 and a negative 4, and neither of my roots are actually the same as those. So therefore, I'm safe. I can use both of my roots as my solutions, and that would all work out perfectly. If it happened, grade 11s, that one of your answers, I'm just going to throw it in there. Let's just say that we landed up with an answer of x is equal to negative 3. If it is the same as one of your restrictions, all you need to do is take a line and draw it through your equal sign to indicate that it is not equal to negative 3, that it is not a valid solution. Okay, so that's what you would need to do in that case over there. However, I'm going to take it out for now because it's not a solution of this particular example. It was just giving us a hypothetical example. Right. Completing the square. I'm sure you guys by now have done this in class. Sure you're all finding it easy, but let's just go through the methods and see. As I'm sure, again, your teacher has really made clear to you, is completing the square is quite a step-by-step logical process. So the thing with this is that you just have to practice it. And genuinely, if you practice the method, the questions all work out to be relatively easy to solve and to get into the completed the square format. Okay, so just practice it, guys. It's really one of those things you got to get under your belt. Okay, right. Completing the square of this equation over here. The first thing we are going to have to do is I'm solving for x. All right, so let's take my whole number of 5 and I'm going to move it over my equal sign. So I'm going to say that x squared plus 10x is equal to negative 5. Okay. If there was anything in front of your x squared, you would have to actually divide everything through by that value. But in this case, there is no number other than 1 in front of our x squared, so therefore I don't need to worry about dividing everything because anything divided by 1 is just itself. Okay. So that step we don't need to worry about. Now we're going to do this. We're going to take the middle term. We're going to take our positive 10. And we are going to multiply that value by a half. And once we've done that, we are going to square it. Okay? So therefore, what I'm going to have is 10 over 2. And 10 over 2 can obviously simplify to 5. And that's going to be squared. So we are sitting with 25. Okay. And what we are going to do with that 25 is this. We've got x squared plus 10x. And we've got negative 5. Now you can see that I've left a gap there, and what I'm going to fill in that gap is this 25 that we have just solved for. What I do to the one side of an equation must be done to the other side. Okay, so therefore that's what we are now sitting with. And this side, the left-hand side of your equation, will now always be a perfect square. So when we factorize it, you want the two brackets to be the same. That's what you can expect. So we'll have x and x. The factors of 25 are going to be 5 and 5. Both of them need to be positive. Okay. And on this side over here, negative 5 plus 25 is going to leave us with just 20. Okay, so instead of writing the bracket twice, let's rather say x plus 5 squared is equal to 20. Okay. Next step, we need to now obviously solve for x. We're trying to get x on its own. So now it's a process of getting rid of the terms until x is sitting on its own. Okay, so squared is the next value we need to get, or next operation we need to get rid of. And the opposite of squaring is to square root. Okay, so I've got x plus 5, which is equal to, and if I square root 20, we are going to have the positive or the negative value of 20, all right? And finally, to get x completely on its own, I'm then going to move my 5 over, and I will have negative 5 plus or minus the square root of 20. Bearing in mind that if you've got a surd, we can simplify those surds, okay? So let's just actually do that quickly. I've got x, which is equal to negative 5 plus or minus. The factors of 20, if I said 4 times 5, that's still equal to 20, except now 4 is a perfect square, all right? So what we can do is take the square root of 4 out of the bracket. So we've got our negative 5 plus or minus, and the square root of 4 is 2, but I'm going to have to leave root 5 as a surd because obviously we don't have a rational value for the square root of 5. So therefore, we're leaving our answer in this case in surd form. However, if your instruction in your test says to 2 decimal places, you're going to take it and type it into your calculator. And remember, if it says to 2 decimal places, it means to 2 decimal places. So please don't ignore that instruction. That's what they wanted to. Whatever the number of decimal places, please make sure you don't ignore that instruction. We follow what we're being asked to do. Okay. Right, guys, I hope you're all understanding that and that's all clear to you. And I've got another example of completing the square. This one over here, just a little bit more involved. And the reason why is because we've now got a number in front of the x squared, which makes it just a little bit more involved in terms of solving. So let's have a look and see over here. Right, I'm going to gather what I've got in my, with anything with an x, I'm going to bring to the left-hand side. And whatever doesn't have an x, let's leave it on the right-hand side. Okay. Now, as I said in the previous example, if you have a coefficient of your x squared, you need to divide everything by that coefficient. Okay. You need to get x squared on its own. So I am going to basically divide everything by the coefficient of x squared, which was 3. All right. Leaving us with x squared minus x, which is equal to 5 over 3. The value in front of our x is a little 1, our little invisible 1. So we are going to take that coefficient of x, I'm going to multiply it by a half, and I'm going to square it. So therefore, we land up with negative a half, which if we square it is going to become positive 1/4. Okay. And if I then take my x squared minus 1x, I'm going to leave myself a little gap here. And I've got 5 over 3. And remember, what we're going to do is inside that space, I'm going to add my 1/4 onto the left-hand side, and I'm going to add it onto the right-hand side. And this side over here, guys, remember, is always going to be a perfect square. So when we factorize it, the 2 brackets are going to look the same. All right, so let's have a look. So I'm going to have my x and x. Factors of a half that are my perfect squares is going to be of a quarter, is going to be a half and a half. Both of them will have to be negative. On this side over here, we're going to have to do a little bit of adding fractions. I'm just going to take that away so that we've got some space to work. I've got a denominator of 3 and a denominator of 4. So when we add those fractions, 3 and 4 both go into 12. I'm going to have to times my 5 by 4, because what we do to the bottom, we do to the top, so we get a 20 over here. And 4 times by 3, so what I do to the bottom, I do to the top, and I have got my 3 over here. All right, so let's, instead of writing the bracket out twice, let's take x minus a half squared. And on this side, we've got 23 over 12. All right. To get rid of our squared, we are going to square root it. So we've got x minus a half equals, and I'm going to say plus minus the square root of 23 over 12. And finally, what we then are going to do is that x is going to be equal to, I'm going to bring my half over, and half plus or minus the square root of 23 over 12, which should then be our solution over there. Okay. All right, guys, so that's then completing the square. It's just your method of completing the square, which, as I said, you need to practice. It's one of those things that we just need to know the steps of. Okay. Right, when we come back, because I think it's time for a break, am I right? We're going to use completing the square to prove the quadratic formula, and that's always really a good test question.
Okay guys, time for a break. I see that there are a whole bunch of questions on the page, so what I will be doing is during the break I'll be taking Tamlin through all of them, because we've only got, I think, about 20-15 minutes left to the show, so we really want to go through the most important ones. So make sure you post your questions onto the page now and go. We'll see you after the break. Hi guys, and welcome back. We are moving into our last, I think, 10-15 minutes of the show. I can't believe how fast it is gone. Grade 11s, I hope that you're still tuning in. Grade 12s, you guys are up next. I need to tell you that we have been doing Learn Extra Live presenter search. We now have our top 15, and we need you guys to vote for your top 10. What you need to do is you need to go to the album in our Facebook page. It's called Learn Extra Presenter Top 15, and you need to like your top 10. So go and like the pictures, your top 10. You'll see all of their profiles there. You can even watch their videos on YouTube, and the links are there too. We cannot wait to have more social media presenters here on the show. So now, I think before we waste any more time, 10 minutes, Tamlin, let's do this.
Let's go, right.
Yeah.
Right, we spoke about the quadratic formula and proving it, okay? Just because we're a little bit short on time and there's so much to get through, here's my homework assignment to you. I want you guys to take your quadratic equation, which is your ax squared plus bx plus c equals 0. That's equals 0, not minus 0. And I want you to complete the square with it, okay? So according to the rules of completing the square that you've learned in school and we've gone over here, and I want you to see if you can land up proving the quadratic formula, because if you do it correctly, you will get the quadratic formula, and we do that by completing the square with your quadratic equation. Please go and try that, guys, because A, it's a very good means of practicing completing the square, and it's also quite a good test question to derive your quadratic formula. So there you go. That's what I'd like you to please try and go and give a try to. If you need help, I'm sure your textbook sets it out quite nicely, so go and have a try with that. Okay, but not to waste time, let's have a quick look at how we actually apply our quadratic formula. Remember, the use of this quadratic formula is if you're now sitting with a trinomial that doesn't factorize. So you've tried this way, that way, all over, it's not factorizing. This is now what you need to use. Bring all your terms to the left-hand side, because that's standard practice with our quadratic equations. And I'm going to write my standard equation formula underneath it. So ax squared plus bx plus c equals 0. Okay. Can we all quite clearly see that the 2, in this case, is the value for a, the positive 5 is the value for b, and the 1, the positive 1, is our value for c. All right. So when we now take our quadratic formula, which is our negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. You are now going to substitute those values into your equation. So nothing more than just careful substitution, grade 11s. You just got to watch out that you don't make a mess of signs or anything like that. The b is a value of 5 plus or minus the square root of b squared, which is going to be 5 squared minus 4. My value for a is a 2. I'm going to have to extend this a bit. And my value for c is a 1. And it's all over the denominator of 2a. And remember, a was the value of 2. Okay. Right, so now we work this out. We're going to type it in our calculators, and we are going to get the answer for our values for x. Okay, you don't have to type it into your calculator. You can work it out manually by just multiplying each of the brackets. The only thing to watch out for is that if you land up with an answer that is negative underneath your square root sign, you are then going to land up with an answer of no real solutions. Okay, so that would be the process of then solving by using the quadratic formula. And I think from there you guys should be okay to finish that one off. So just sub in carefully. Watch out for signs. Don't forget that if a sign is a negative, let's just say, for example, that 5 was a negative, then into the value for b, you would substitute negative 5. So do watch out for the sign. That does belong to the value of the a, the b, or the c. Okay. Right, before we waste any time on this, I want to go on to this finding the maximum and the minimum value of a quadratic function, okay? Any quadratic function, all right, when we sketch it, becomes a parabola, all right? And I'm sure we remember from last year, our parabolas are our smiling and our frowning functions, to give it nicknames, okay? Now, if we remember from last year, if I've got the standard equation of ax squared plus bx plus c, all right, if our value for a was positive, so in other words, it's greater than naught, do we all remember that we would get a parabola that would basically look like something like that? It would be smiling, okay? So the turning point of our parabola would be right down there at its minimum value, all right? And if our value for a was less than naught, so in other words, it was negative, we would get a parabola that would be frowning. And it would look something like that. So my turning point would be at its maximum value, all right? So therefore, I hope this is starting to make sense to you guys. What we need to do is we need to, if we're trying to work out the maximum or the minimum value of a quadratic equation, we need to calculate its turning points. We need to work out where are those maximum and minimum values. Now, this is something you might not have learned just yet. The quadratic equation in the form of ax squared plus bx plus c can also be written in the form of a bracket x plus p squared plus q. And the way we get from that form to that form is by completing the square with it. Okay. Now here's the important thing to remember. When it is in the form of ax squared, when it's in this form over here, ax plus p squared plus q. The value of our p and the value of our q, when we solve for p and we solve for q, please watch out here. If I were to solve for p, all right, if x plus p was equal to naught and we solved for p, we would land up with a value of negative p as the answer. So please remember this. Negative p and positive q form the coordinates which make your turning point in your parabola or your quadratic function, okay? So, can we see where we're going with this? If we take our equation, we complete the square with it to get it into the form of a x plus p squared plus q. We can then straight away, just by looking at the equation, determine the coordinates of our turning point, and from there we quite easily can see what the maximum or the minimum value of the equation is. So, let's do this as an example. We've got the equation 2x squared plus 4x minus 2. All right. I'm going to complete the square with it, but I'm sure some of you are sitting there thinking, hang on, but where's the equals naught? Okay, there's no equal naught here. And you're absolutely right, there's no equals naught. So one of my steps which I used previously was to move the whole number over the equal sign, and now I can't. Okay, so we're going to have to work around that. We're going to have to divide everything by, and I'm going to rather take it out, sorry. So let's take the coefficient of my x squared out, because remember we don't want anything in front of x squared, which means that everything gets divided by 2. So it means I've got a plus 2x and I've got a minus 1 inside my bracket. Our next step is to take the middle term, so we take our 2, we multiply it by a half, and we square it. Somebody earlier was asking, do you always multiply it by a half? The answer to that is yes. Okay, you always times it by a half. This then cancels to give us 1 squared, which is 1. Okay, so what do I do with this 1? Because normally what I would know to do is I would add it onto the left-hand side and I would add it onto the right-hand side of the equation. But I don't have a left-hand side and a right-hand side. So this is what you do, guys. You take that 1 and you add it, okay? But remember, you can't add something without essentially taking it away. Otherwise, you're changing the value of the sum. So I'm going to add 1, but I'm also going to minus 1, okay, which looks kind of weird for now, I know. But let's have a look, and I'm going to then have this negative 1 on the end over here. Okay, so what I've done is I've really just added a plus 1 and a minus 1 into the middle of that bracket, okay? And the reason why this will work is because what we're going to do is we're going to group the first 3 terms together. And by grouping the first 3 terms together, we are going to create a perfect square, which is going to be x and x, 1 and 1, plus and plus, and minus 1 is minus 2. So, instead of writing the bracket twice, let's say x plus 1 squared minus 2. And what we mustn't forget is that this 2 does need to distribute back into both terms of your bracket. Okay, so if we distribute it back into both terms of our bracket, we're going to have 2x plus 1 squared minus 4. Okay, now remember we said right back in the beginning, if the a in my equation is greater than 0, my parabola would be smiling and I would have a minimum. If my value for a is negative, my parabola would be frowning and I would have a maximum. So let's have a look. Now the a is the value in front of our bracket. So if I have a look at my value for a, we can see that that's positive. So what I know is that my graph is going to be a smiling graph, okay, just by means of its shape, okay? So therefore we're looking at a minimum value. So that's at its turning point. And we said earlier that the way we determine the turning point when we have it in this format over here is we take the coordinates of the negative p and the q, which means that if this is a +1 inside my bracket, I would have a turning point at -1 and -4. All right? So therefore, what is the y value that is at the lowest y value of your parabola? In this case, it would be at -4, which is therefore the minimum value of that quadratic equation. So that's how we do it, guys. We change the format from ax squared plus bx plus c into the format of our a bracket, x plus p squared plus q, and we do that by completing the square. And the negative p and the q are your turning points, okay? And that will tell you what the maximum or what the minimum value of your quadratic equation is. So I hope you guys all understood that. It's still just completing the square, so we still just follow that same process. I think we've got a little bit of time left over, so let's see if we've got 1 or 2 minutes to have a look at something else. Okay, I doubt I'm going to get through all of this, but I am going to set you on the right path, and we can hopefully get through some of it. Here's a nice practical example, guys. So this puts theory into practice over here. They've said that a farmer plans to construct a rectangular closure for his sheep using 100 meters of fencing. He makes use of an existing wall as one side of the rectangular enclosure. So we have to calculate the dimensions of the rectangle so that he can get a maximum enclosed area. So because this is already an existing wall, the perimeter of my fencing is only this part here. All right, and they've said that we've got 100 meters available of fencing. All right, so therefore the perimeter of my fencing is going to be, remember, if that over there is a length of x, then this over here would also have to be a length of x. So if I took the perimeter of my fencing, I would have x plus y plus x, which if I add my x's together is going to give me 2x plus y. And don't forget that we know what the length of that perimeter is. We knew that it was 100 because they said we had 100 meters of fencing available. So I've got 2x plus y. Now the reason why we start off with this is because we need to write y in terms of x. So you need to move x over and say 100 minus 2x is equal to y. So therefore we're not working with y anymore. We're going to refer to it as 100 minus 2x. Okay. The idea now is that we now actually have to find an equation for the area of a rectangle. And the area of a rectangle we would calculate by saying length times breadth. So in other words, x times by 100 minus 2x. That gives us a quadratic equation. To calculate the maximum value of that quadratic equation, you are going to take your equation that you've worked out for the area, you're going to complete the square with it, and once you've got it into your format of your a, x minus p squared plus q, the p and the q form the turning point, and that will give you your maximum area that the farmer is looking for. Give it a try, guys. It's just applying the rules that we have taught you. So it's nothing new, it's just application, which is really important to practice. And that's all that I have for today.
Okay, guys, I know that is a lot to take in. Keep posting your questions on the page. Mindset is help each other out. And grade 12s, don't you be forgetting that you guys are next. Big up to Macmillan. Thank you so much, guys, for making this show possible. It has rocked. All of the content that has been taught was from the Macmillan textbook. So you guys are amazing. So big thank you. Everyone has been enjoying the show. Let me have a look here. Lucinda, hey, she knows exactly what's going on. Guys, if you don't know, please post into our page. But for now, grade 11, see you same time, same place next week. Bye.